Welcome back to my chemistry lessons. Today we are going to discuss about the electronic configuration. In order to write the electronic configuration of an atom of an element, we have to go strictly on following rules. So the first one is Aufbau principle, second one Pauli's exclusion principle, and third one Hund's rule of maximum multiplicity. So Aufbau principle or building a principle is when you write the electronic configuration of an atom in its ground state, the electrons occupy the lowest available energy level first, then next energy level, and goes on. For example, 1s has lowest energy level and 2s has higher energy than 1s. So 1s has to be filled first, then 2s, then 2p, 3s, 3p, and goes on. And this concept is called Aufbau principle. And next one is called Pauli's exclusion principle. According to Pauli's exclusion principle, no more than 2 electrons can occupy in an orbital, and they must have opposite spins. So this is very important. So one orbital can occupy 2 electrons. The condition is they must have opposite spins, either plus half or minus half. The electrons are spinning in the orbital itself, either in a clockwise direction or anti-clockwise direction. If the spinning nature is on clockwise direction, it has plus half spin, and otherwise it is called minus half. So third rule or third law is Hund's rule of maximum multiplicity. When electrons are filling in orbitals of same energy, that's important, orbitals of same energy, electrons occupy singly first, then filling them in pairs. For example, in nitrogen has atomic number 7. So according to Hund's rule, we can write 1s2, 2s2, that's a 2p3, that's electronic configuration, 1s2, 2s2, 2p3. But according to Hund's rule of maximum multiplicity, 2px, 2py, 2pz, they're called degenerate orbitals, and they have the same energy. In previous my lessons, you can see I have explained that px and py, pz, they have a only difference in their orientations on x, y, z axis orientations. So they have same energy. So electrons filled the 3 electrons. First one goes to px orbital and 2py orbital, then 2pz orbital. So singly first, and after you fill in them singly, if you have another electron, so if you go to oxygen, next atomic number 8 electron go to 2px2, and if you go to fluorine, that goes to 2py2, and in neon the last electron goes to 2pz2. So 1s2, 2s2, 2px2, 2py2, 2pz2 in the case of neon. So that concept is called Hund's rule of maximum multiplicity. And there's another important thing. So when you write the electronic configuration, I am not discussing all those things, just important points. I just noticed this thing, so I just would like to share with that to you guys. Okay, so chromium and copper. When you write the electronic configuration, 1s2, 2s2, 2p6, neon, up to that, and 3s2, next level, that's M shell starts from here, 3p6, and 4s1. See, it's supposed to be 3d orbital here, but it comes 4s1. See, 3, 3, 3. The 3d need to be there. But why this is happening? And if you go to copper, the same thing you can see. The 4s keeps singly, and 3d get paired, and 3d here gets 5. So this is a half filled. There are 5d orbitals. So they are singly filled, and here all the d orbitals are filled in pairs. That's a 3d10 copper. So the reason why they keep in this kind of electronic configuration is because of extra stability of half-filled orbitals. Half-filled and fully filled orbitals have extra stability. Keep that in your mind. Okay, and there's another explanation. That's a beautiful explanation. It's based on the n plus L value. The orbitals, according to our building up principle or offer principle, they're saying the electrons were filled in the lowest energy level first. So that's based on the n plus L value. N is a quantum number, L is another quantum number that will go to that area another time. So for timing, N is a quantum number and L is another quantum number. So N is a principal quantum number, L is an azimuthal quantum number. Okay, we leave that now at the moment. So N plus L value. So N is numbers, starts from 1, 2, 2, 3, 4, etc. And L is an azimuthal quantum number. It also has some values. It's based on the shape of the orbital. Okay, here, if you're considering for us, the N value is 4 and L value for S orbital is 0. So it has a 4 plus 0, 4. That's a value of N plus L value of 4s orbital. And in the case of 3D orbital, 3 is the value of N, and for D orbital, the value of L is 2. So 3 plus 2, 5. So 3D has higher N plus L value. That's why they came after 4s. So that I will discuss in later in my videos. So leave that at the moment. Okay, so so there is another important point. What's isotopes and isobars and isotons? Okay, isotopes, atoms have same atomic numbers and different mass numbers are called isotopes. For example, hydrogen has 3 isotopes, protium, deuterium, and tritium. So the only difference is on the mass numbers. See, 1, 2, 3. Atomic numbers are keeping same. So same atomic numbers and different mass numbers. And here isobars, just opposite of isotopes. So they have a same mass number, different atomic numbers. You can see there's nitrogen has atomic number 7, but the mass number 40. And carbon has atomic number 6, mass number same as nitrogen, so 14, 14. So they are isobars. And there's a third type of element, group of elements called they shows the property isotons. So atoms having same number of neutrons and different number of protons. So different number of protons means different atomic numbers, but they have the same number of neutrons. For example, you can see carbon C6, 14, and oxygen, different element, 8. Here is a 16, and there is another one, nitrogen, 7. There is 18, 16 again. So when you take the difference between the mass number and atomic number, that will be the number of protons. So here 14 minus 6, 8, and 16 minus 8, 8 again, and here is what is 15 minus 7, that is 8 again. So the number of protons is 8. So they're called isotons. And that's about the electronic configuration and half-filled, fully filled orbital stability and isotopes, isobars, isotons. And thanks for watching, and God bless.